Hi there, and welcome to another chapter of the electric BMW 320i project. Well, you got to see my last video where I finally showed driving the car. Well, this video is going to show how I got to that point. It's basically just a bunch of video that I've been taking over the last 3 months since I did the last video, but I wanted to get the one out that showed me driving the car. There's certainly going to be more of those. As I get more and more of the car built, I have to get that car to the point where I can get it inspected, so then I can actually drive it around on the street and do some testing. I really want to see what kind of energy use it's going to use, but for now I have a video that shows all the fun I had with the brakes, and then all the fun I had with the contactor box and what I had to do to fix that. So let's take a look at that. Getting closer to being on the road, weighing it one last time. Everything's in it except the hood, which is 53 pounds, which will be always over the front wheels, so just add that in on each side. So let's take a look. You can see total weight's 2815, 2814, and pretty well even front to back, which is good, except for that front right is a little low, but it's probably because the spring's designed for passenger. But that's really good news. The hood would add another 50 pounds, so that'd make it 2860, probably 63, 64. Alright. Well, just one last thing to do, and that's get the brakes bled. And that's going to be quite a fun thing, but that's the only thing left to get this on the road. Well, this doesn't look good. Here's the master cylinder and reservoir and booster out of the car, and lots of brake fluid around. What's going on? Well, started calibrating the rear brakes and for the pressure transducer, and no pedal. So there's a leak somewhere, even though there's no brake fluid, it's air getting in. So I have to find it and figure out where it is. I built this little cable out of all these fittings. I've learned that you want to do anything, you gotta convert everything to AN, and then you can make junctions and get other things like an adapter to go to pipe thread. So I'll be pressurizing that and see if I can find if there's a good flow of fluid or not. And if there isn't, then it's probably this little puppy down here, that thing, with the blue top. That's a proportioning valve, which proportions the rear brake pressure with respect to the front brake pressure, so that you apply less pressure to the rear brakes, because they would tend to lock up otherwise. And that could be even a bigger problem with what I've done on this car, is put the disc brakes on the rear, and so that has more stopping power, but the front has bigger discs and bigger pads, so it's actually stopping more, so it might just actually even out. But this will be tomorrow's project, is doing that pressure test. Alright, well, I was able to remove the proportioning valve and replace it with an adjustable one. You can see there it's mounted, it's upside down, but that's fine. Unfortunately I have to crawl underneath the car to adjust it, but that's a Wildwood adjustable proportioning valve. Here's the box from it, and yeah, that definitely was the issue when I tried to put brake fluid through the system with the portioning valve in there. With this fittings I set up, couldn't get any flow out of the rear brakes, so that was definitely the problem. So now with that in, I'll test it, and if that works, everything goes back together and I should have some brakes soon. Got the master cylinder installed and the brake lines, and now starting out doing the pressure bleeding. So see how it goes, see if we can get all the air out of the system and actually have brake pedal. One more thing, I put that big zip tie around the reservoir just to make sure it doesn't go blowing off with this pressure I'm putting on there. I just, unlike a lot of the US stuff that they make the reservoir integrated with the master cylinder, this one just plugs into a couple of gasket seals. So I mean, usually there's no pressure on that side, but when you do this pressure bleeding, yeah, there's like 20 psi on there, so that's just a safety factor. Well, after about just 5 minutes, it's already pushed through a quarter of a liter, so still haven't seen the air bubbles. But that's flowing a lot better than it did before I replaced that proportionating valve. Even after pressure bleeding another whole liter of brake fluid through both rear calipers, I still did not have a brake pedal. It just went right to the floor, so meaning still a lot of air. And I realized the problem must be that the bleed screw is not straight up, but at a 45-degree angle, like shown in this photograph. And that any air that was trapped in the area where it's arrowed would just not be expelled, because the brake fluid would just go right past it. And what I decided to do was to fix this was I actually had to take the brake calipers off the hubs, and with the flexible brake line still attached, rotate them around so now the bleed nipple was straight up in the air, and then I was able to pressure bleed the caliper like that, and both calipers had a ton of air in them, so that was clearly the problem. And after I bled just a little bit of brake fluid through both, I got a brake pedal, and I was able to also see a pressure in the pressure transducer. So I know that that had to be the problem, and unfortunately this is going to be an issue if I ever get air in the brake line again and have to bleed the calipers this way. But it worked, and that's all that's important. So now I have brakes and I can be able to drive the car. Here's how I solved my contactor problem. I just put up a new contactor here in the trunk with the pre-charge resistor, and I got a little Arduino Dewey with the relay board, 12-volt relay board, so that controls the timing of turning the main contactor on here, so everything should work. And this is all tied to my 12-volt system, the EV 12-volt system, so if I turn off anything, the inertia switch or the front switch or the key shuts all this down and opens that contactor. So it's a way to shut off the high voltage. Probably going to be where the contactor is maintained. I'm just going to have to put this all in a box back here, but a lot easier to work on this than the one that's in the engine compartment. Well, here's a test of this new device I got. It's the let's see here, they call it the Smart Precharger. This company in Australia, and supposedly it looks like it's an active load for the precharge to the DMOC, so it automatically then switches in the contactor after it senses that the voltage has dropped enough. So we'll test this out and see how it works. 1,000, 3,000, 4,000, 5,000. So it doesn't look like it's going to work. Hasn't made the relay, and it should have contacted that. That sucks. Try it again. Yeah, the volt's still looking like 200 volts across the relay, and it's not really doing anything. Oh well, I was afraid it might not work. Here's a graph of the voltage across the contactor, and you see it didn't get down in 5 seconds what it needs to hit 10 volts, and it only got down to 60, so that's not going to work, so I have to go back to the resistor recharge. After testing everything, I decided just to go back to this Arduino Uno with a relay shield, and I have two 50 ohm resistors in series to make 100 ohms for the pre-charge resistance, and two contactors which are driven by the little program running in the Uno, and then a fuse which was back here in the back part of the output from the last part of the battery box. So that seems to work pretty well. I did find that 100 ohms is a good pre-charge resistance. Show you the graph here pretty well. With just the DMOC, it pulls it down to very low voltage in a short amount of time. With the DC converter connected, unfortunately, in 5 seconds it's still at about 70 volts, but 70 volts is a very small amount of current to switch one of these big contactors, so I don't think it's any problem, and this is the way I'll be going. I still have to take apart the box in the front and figure out what's going on with that, and either replace or jumper around the contactors that are broken. Alright, I'm going to try moving the 320. It's the first time it's moved under its own power since January 2014. Just got to move it out of the garage so I can do some work on the front end. There goes the vacuum brakes. That works. Probably needs to be adjusted a little bit, but let's see how it goes. All right, it moved. There it is, first time out of the garage in more than 2.5 years. This needs a bath. It's really dusty, but it's looking good. So I'll just have to get these last few things under the hood. Just a little bit of paint, you can see in those areas kind of chipped up, and clean it up a little bit, and then the hood can go on and go for a ride. Okay, all cleaned up and taped up and ready to paint. Of course, when I got this done, the wind picks up. Wonderful. And voila! Here we go. That came out pretty good. Not bad for a spray can. Of course, it's just a really rough area. I can't tell how smooth it will be when it's dried, but looks good. In preparation of my first test drive, I got the hood attached. Boy, that wasn't easy. I didn't see it come off because when I delivered a car for having the ice taken out, when I got there they already had the hood off, so I didn't see how it was attached. But boy, those little guys there, they were really hard to get back in there and bolt up, and very tight, but that's good, it works. And now I have a hood so I can go for my test drive. So you can see quite a lot of work on the brakes. It's crazy. That was a kit that I found online that was designed for an E21 BMW. I found another website that showed it being installed. Looked like really not that difficult, but maybe partly my inexperience or maybe the kit. It just it was really difficult, and also that whole thing about taking them off and having to turn them upside down to get them to bleed properly, that, well, I think could only come with experience of doing that many years. It's just lucky I figured it out. And I do think it's worth it because disc brakes really are needed on a car that goes fast. I mean, you see any sports car or race car that has a lot of acceleration, you have to have a lot of deceleration. And as I found out driving this car, yeah, it's going to have a lot of acceleration. So it's great that it is rolling, and I just have to get more things done, specifically to get the car inspected by the state. Nothing that's special there, it just has to have all the parts to it working. And there's still a few things that need to be done, like finishing the interior and getting some more of the pieces in the engine bay put together, and making sure all the lights and tail lights and brakes and everything work perfect, so there won't be any issue and it passed. Because I really can't drive it on the road till it has an inspection sticker, at least not without risking getting pulled over. And I really don't want to get pulled over in that until it's really working well and explain what it is. But hopefully I will get the car running and have a lot more videos showing the car being driven than being worked on. But that's how it is with any project like this. But again, thank you for watching, and watch for the next video. If you want to see more of the 320 in action being driven around, click the link above, and that will take you to the last video that has all the fun stuff driving that car around for the first time.